Okay, so today we're going to talk about what are solutions to a system of inequalities. Notice these are called inequalities because these are lines and they shaded above this line. So that is the greater than or equal to symbol. And then they shaded below this dashed line. And because it's dashed, it will not have a line underneath. So this is the less than symbol because they shaded below this line. So whenever we have symbols like this or like this, less than and equal to signs, or greater than or equal to signs, these symbols are called inequalities. Okay, and that is what we are going to be talking about today. So let's look at this graph closely. Notice that, let me clear this. Notice that points here, here, and here, these points are not solutions. And these points are not solutions. The reason why they're not solutions is because it's not in the double shaded part. This side here is shaded red, and it is also shaded green. Okay? So because it's not in the double shaded area, these are not solutions. Notice this is not a solution because it's not in the shaded area at all. Notice this is not a solution because one, it's not in the double shaded area and it's on a dashed line. These 2 points are not solutions because they are on a dashed line. Solutions are not located on dashed lines. The only solutions that we have are these dots here. These are valid solutions because they are in the double shaded area, and this one is a solution because it's in the shaded area and it's on a solid line. Okay, so let's look at some examples. Here's the point 0, 0. That is right here. This is not in the double shaded area, so this is not a solution. The reason is because it is not in the double shaded area. The next point is 3, negative 4. That is right here. This is not a solution because it is on a dashed line. 0, negative 2 is right here. That is not a solution because it is not in the double shaded area. So I'm going to put a star here. This is the same reason. 3, 1. That is a solution because it is in the double shaded area. It's on a solid line, so it's okay. 5, negative 2. That is in the double shaded area. So this is a solution. It's in the double shaded area. Okay, so our conclusion is that solutions are only in double shaded areas. Another important conclusion, and sorry I wrote that sloppy, this says only. Solutions are only in double shaded areas. Now, another important conclusion that I'll write over here, solutions cannot be on dashed lines. If it is on a dashed line, it is not a solution. Okay, so let's talk about this point right here. Let me erase these points so that we only focus on the one I'm talking about. I'm going to erase these points on my graph. I want to show you this point right here at the intersection. This point is not a solution. The reason, not a solution. The reason is because it's on a dashed line. Because it's on a dashed line. Solutions are not on dashed lines. Okay? Let's go on to the next example. So we saw that we can graph these two lines and see what points are in the shaded area. Well, we can also figure out if this point is a solution, not by looking at the graph, but also just plugging the points into the problem. So I'm going to write the first one down. This says y is greater than or equal to x minus 5. Now, this is the x value, and this is the y value of the point they gave me. So I'm going to erase the x, and in its spot, I'm going to put 3, because that's what they gave me. And then I'm going to erase the y, and I'm going to put a 2. And then I'll just evaluate to see if this is true or not. So 2 is greater than or equal to 3 minus 5 is negative 2. This is a true statement. If you thought about a number line, here's 0, 1, 2, here's negative 1, negative 2, and indeed, 2 is the bigger number than negative 2, okay? 2 is greater than or equal to negative 2. That is a true statement. Let's test the other equation. So I'm going to write this down. 2x minus y is less than 4. Again, I'm going to plug in the point that they gave me. I'm going to erase the x, and I'm going to substitute a 3 in its spot. I'm going to erase the y, and I'm going to substitute a 2. So 2 times 3 is 6, and I'm going to subtract 2. Now let's evaluate this. 6 minus 2 is 4. Is 4 less than 4? No. This one is false. So, since they were both not true, 3, 2 is not a solution. It has to work for both inequalities, not just one. So this is not a solution. Okay, now let's look at another example. We're going to graph these. So I'm going to do my easy one first. This one looks easy. I can directly graph this. This is my y-intercept. So I'm going to start at 4 and put a point. So on the y-axis, I'm going to put a point at 4. Then my slope is up 1 over 2. So go up 1 space over 2 spaces. And we can continue this line. And I can go this way as well to continue the pattern. This will be a dashed line. The reason why this is a dashed line is because it doesn't have a symbol underneath. When you have this symbol, it's a dashed line. If you have the equal sign underneath, it is a solid line, okay? And this is the less than symbol. The way I like to remember it is this symbol looks like the letter L for less. So it's saying the y values need to be less than this line. So the y values that are less than the line, let's look. This is the y value 6. This is 5. These y values are smaller on this side. So I'm going to shade the less than side. I want the y values that are less than, and that is this side of the line. Okay? So we're going to shade below. Less than is below. So we're going to shade below the line. Okay, now let's do the next line. Let me clean up this board a little bit. Let's do our next line. So notice my next line is not in slope-intercept form, so I have to do some algebra before I graph it. So I'm going to write this this inequality down here. 2x minus 3y is greater than negative 12. So first, I'm going to move this 2x to this side of the inequality. So the negative will remain a negative. 3y will stay the same. My symbol doesn't change. This minus 12 doesn't change. The only thing that is changing is that when I move 2x to this side, it will now become a negative 2x. A lot of students forget to bring down this negative sign. Don't make that mistake. This is a negative 3y. Now I'm going to divide everything by a negative 3. So I need to get rid of this negative 3. I'm going to divide everything by negative 3. Now, the rule is, I'm going to write this right here. If you multiply or divide by a negative number, you need to change the sign, okay? You need to write that down somewhere. A lot of people forget this fact and they make a big mistake and they don't get the question right. Okay, so this remains y. I'm dividing by a negative number. If you divide by a negative, this sign will now face the other direction. You have to change the sign. A -2 divided by a -3 will be positive. So this is now a positive fraction. -12 divided by -3 is a +4. So this is the line that I am going to graph. Okay? Now I hope you wrote down that part in your notebook somewhere. I'm going to erase this so that I can draw my line. Okay, so let's go ahead and graph the line. I have my y-intercept is at 4, so I'm going to start at 4. And then my slope is 2/3, so I'll go up 2 over 3. Up 2 over 3. I can also go down to this way 3. Down to this way 3. And this will be a dashed line as well. So notice, this is the less than symbol, so that means I need to shade below the line. So I'm going to shade all of this below this line. I'm shading below this line. And let's look at the part that's shaded twice. I will highlight it for you. So it looks like this part is shaded twice. And then this part here is shaded twice. So this is the part that's shaded twice. So let's talk about what my solutions are. I'm going to give you some examples of a solution. Let's see, is this point a solution? The answer is no, because it's on a dashed line. This point is a solution. This point is a solution. All of these points that I'm drawing right now are solutions because it's in the double shaded area. Okay? This is not a solution because it's on the dashed line and it's not in the double shaded area. This is not a solution because it's on a dashed line. Okay? And this point here, that's not a solution because it's not in the double shaded part. That part's not highlighted twice. Okay, so that's how you do that. Let's see if there's more examples here. Okay, this says y is greater than x. You can imagine your y-intercept being 0. So you start at 0, and then my slope is just up 1 over 1. I'll go in both directions. And this will be a dashed line because there is not a line underneath. So this is my line. And this says greater than. This is the greater than symbol. So you need to go at your line and go up. Start at your line and go straight up. This is the side that you shade. Also notice these y values up here are greater than the ones down here. So that means we're shading the correct side. We want to shade the greater side. And these y values are greater up here than they are down there. Okay, now let's do the next line. This says y is less than x minus 1. So my y-intercept is at -1. And my slope is the same, up 1 over 1. So this is my line. Oh, these lines look parallel. They're not touching each other. They have the same slope. So this is the second line. and this is the less than symbol. So I'm going to go below the line. These y values are less than, look at these y values here. These y values are less than the ones up here, right? So I'm shading the correct side. I want the lesser side. Okay, so we're going to shade this way. So do you guys notice? None of these parts of the graph are double shaded. There's no overlap, so that means there are no solutions. There is not a point that is in both the red or the blue, so there is no solution. Let's do the next example. So I'm going to start with this top equation, or inequality. This says 5x is greater than 10. Well, let's get x by itself. I'm going to divide both sides by 5. So I get x is greater than 2. So I'm going to go to the x-axis at 2, right here. And I'm going to do a dashed line. So this is my line. A lot of students draw it wrong. Let me show you what the wrong way is. The wrong way to do this would be to go to 2 and then draw a horizontal line. Well, that's not right, because this line goes through all the x values. This line passes through 3, this line passes through 4, this line passes through 5. That is not the line x equals 2, okay? We just want it to go through the x value too, not all the other ones. So whenever you have x in a number, it's always going to be vertical. Now let's read what it says. This says x is greater than 2. Well, the x values that are greater than 2 are on this side, right? These x values are greater than the ones over here. So I'm going to shade the right side of this. So we're going to shade this side. Okay, now let's do the next problem. I'm going to erase this, and I'm going to do the next equation. I'm sorry, I keep calling them equations. They're called inequalities. These are called inequality symbols, not equal signs, so they're not called equations. So my equation is x minus 2y is less than or equal to 6. I'm going to move the x to the other side, and remember, everything else will stay the same. The negative 2y will stay the same. This 6 will remain a positive 6, so go ahead and put a plus sign there. But the only change is when x goes to this side, it will now be negative. The sign will change, okay? Now, I'm going to divide everything by a negative 2. So y is now by itself. If you divide by a negative, the sign will change. A negative over a negative will be a positive. So this is positive x over 2. A positive 6 divided by a negative 2 is a negative 3. So let's go ahead and graph it. I'm going to start at the y-intercept. This is the y-intercept. So we're going to start at negative 3. So I'm going to plot a point at negative 3. And my slope, I know that I go up 1 over 2. Up 1 over 2. And if you're asking, Miss Lewis, how do you know you're supposed to go up 1? Just imagine a 1 in front of the x. So you go up 1 over 2. And we can also continue the line in this direction. So this will be a solid line. And we're going to shade above, because that's a greater than symbol. So that means solutions are located in the double shaded area. So let me give you some examples. Is this a solution? That's the point 2, 2. I hope you said no. It's not a solution because it's on a dashed line. So that's not a solution. What about 3, 2? That's a solution because it's in the double shaded area. What about this point right here, 4, negative 1? Is 4, negative 1 a solution? The answer is yes, because it's in the double shaded part and it's on a solid line. It's on a solid line, so that's okay. That's a solution. What about 2, negative 2? Is 2, negative 2 a solution? The answer is no, because even though it's on the solid line, it's also on a dashed line. It cannot be on a dashed line. Next, I have y is less than 0. So this is the y-axis, and here is 0 on the y-axis. So I'm going to draw a line that goes through 0 on the y-axis. This is the horizontal line that passes through 0 on the y-axis. So that's my line. And it says y is less than 0. So less than would be down here. These are all the y values that are less than 0. So this is the side that I need to shade. Less than, you need to shade below. Okay? Less means you shade below. Okay, now let's do the next line. This says x is greater than or equal to 0. So go to the x-axis and go to 0. I'm going to draw a line through it. So that'll be a solid line through 0. This line that I just drew in red, it crosses the x-axis at 0. Now let's see how we're going to shade. It says x is greater than or equal to 0. Well, the x values that are greater than 0 are on this side, right? 1, 2, 3, 4, 5, 6, those numbers are greater than 0. That means I'm going to shade this side. So that means my solutions, I will highlight the solution area. This is the solution area, what I highlighted in yellow. Okay? So, quick question. Is 0, 0 a solution? No, it is not, because it's on a dashed line. Look, this purple line here is dashed. Solutions cannot be on dashed lines. I know this is on a solid line as well, but if it's ever on a dashed line, it does not matter. It is not a solution. All right, so that is the end of our notes. I hope that helps.